Welcome to the technical analysis of a boat shaped like a Su-27, cleaving the waves. The excellent hydrodynamic design helps the machine glide at high speeds and make sharp turns. The low center of gravity and water jet steering system operate extremely stably on the river. Let's go back in time to watch the manufacturing process. A two-stroke engine is prepared and ready. The craftsman uses chalk to sketch a 1:1 scale outline right on the floor as a reference. The core material consists of purple SPS foam boards. A utility knife is used to precisely bevel the edges. Applying specialized glue, he bends and presses the foam boards together to form a V-shaped hull structure. Next is sketching the curves. He cuts semicircular pieces to act as internal load-bearing bulkheads. Each bulkhead is measured for spacing and secured to the main spine using CA glue. The dense distribution of bulkheads helps disperse force. Vertical panels are added to create a frame matrix. Glue is applied along the contact lines. The foam frame is lightweight, but thanks to the box structure, it's very rigid. Bending a metal strip to make a DIY compass, he draws a perfect arc to cut the bow frame. The characteristic elongated nose frame of a fighter jet gradually takes shape. The joints are carefully sealed with glue, measuring angles, carving, and cutting thin foam strips. The manual shaping technique requires high patience. The surface skinning phase begins. Large foam panels are applied to follow the curves of the load-bearing framework. To hold them in place while the glue dries, he uses a drill to insert temporary screws through the shell into the frame. The trimming of the excess edges is very decisive. The aerodynamic conical nose block is basically complete. Quickly noting down material calculations on his hand, using pliers to bend a small steel rod to serve as a shaft centering core, cutting a series of additional round foam discs. They will shape the combustion chambers and jet air intakes on both sides. The foam discs are glued in sequence. The empty space in the middle will form an aerodynamic tunnel, sketching the entire wing body plan on an oversized white foam board. Using a tape measure to draw straight lines, a utility knife cuts out the delta wing profile. This is the monolithic base for the entire hull. Flipping the wing section over, he test fits the previously built fighter nose to adjust the overall proportions, proceeding to build vertical bulkheads for the cockpit and rear fuselage, continuously pumping glue along the contact edges. The cordless drill and screws are still used to firmly press the foam panels together, ensuring the frame does not shift. Installing X-shaped diagonal bracing, a spirit level, is used to check for absolute balance. Moving on to edge wrapping, thick foam strips are applied to the outer edges to create borders for the main wings of the aircraft. Starting the planking technique for sharp curved surfaces, narrow foam strips are bent along the contour of the wind tunnel, continuously carving and trimming excess edges. The adhesive seeps into the gaps, creating a seamless surface. The planking process takes a lot of time, but it yields an extremely precise aerodynamic curve. Applying more glue to seal the seams. The sidewall frames are fully covered, hiding the complex internal structural matrix. The horizontal struts are measured and cut to fit snugly, locking both side walls in place. This reinforces against torsion. Continuously applying glue and attaching secondary load-bearing panels, the core foam structure has achieved the minimum required rigidity. The utility knife blade glides smoothly through the foam. He is shaping the curved trim. The glue continues to be applied evenly. The undulating trims create aerodynamic shapes, assembling the dorsal shell and cockpit canopy onto the frame. The monolithic design is clearly visible. The giant vertical tail wings are test-fitted. The Su-27 proportions are excellently simulated, mixing a specialized putty compound. The fast-curing chemical fills the gaps. A plastic spreader evenly smooths out the white putty layer, covering the rough joints. An angle grinder with a high-speed sanding disc grinds down the putty. The surface becomes smooth. Mixing an additional layer of fine yellow putty, the craftsman carefully spreads it to completely eliminate any pitting. His hand feels the smoothness. Thin plastic edging clings to the edge to create sharpness. trimming the plastic edge to closely follow the body curve. The details of the foam mold are perfect, using solvent to clean off dirt from the surface, preparing for the composite molding process. Applying a layer of non-stick mold release wax. This step is crucial to protect the mold. The red gel coat layer is rolled evenly onto the surface, determining the gloss of the boat's hull. Applying a layer of woven fiberglass mesh. Polyester resin mixed with hardener is pressed firmly to remove air bubbles. A metal roller carefully smooths out complex corners, ensuring the composite fibers are completely saturated with resin, waiting for the resin to dry before trimming the excess edges. Applying yellow tape to mark the waterline boundary. Measuring the draft line. Brushing on the red gel coat along the curves to create a decorative border. Wet sanding the gel coat surface. A white resin layer is applied over the entire underside of the hull. The composite cures. Drilling air release holes. Using a hammer and chisel to wedge into the mold release edge. Prying off the excess composite edges. Peeling off the warning tape layer, revealing a beautiful seam. Using a machete to pry forcefully along the edge. The cracking sound indicates the shell is separating from the mold. Splitting the nose shell section in half. The wax layer works perfectly as a non-stick agent, keeping the core mold intact. Coordinating smoothly. The team lifts the giant fiberglass back shell off the mold. Using a punch tool to break the internal foam joints. An angle grinder smooths out the edges of the composite shell, cleaning and sanitizing. Pumping water and scrubbing dirt out of the hull to increase adhesion. Brushing gray base coat resin into the hull. Adding strips of reinforcing fiberglass. Applying a thick layer of epoxy resin. This fiber layer acts as an internal skeleton to prevent the hull from cracking. Applying a highly thick mixture of resin and redstone powder along the spine to stiffen the main axis. Adding another strip of fiberglass over the spine and smoothing the resin. The structural frame is now indestructible. A grinder bevels the edges of the boat's hull to prepare for the hull assembly process. Aligning the edges, drilling pilot holes and bolting them temporarily. The boat has now taken shape, crawling right into the nose cone. The craftsman uses a grinder to smooth out the connecting ridges inside the hull, moving on to the triangular wing sections. Sanding the foam surface flat, then attaching round wooden rods to serve as load-bearing ribs. Assembling the nose cone to the main body. The joint edges are filled with strips of foam padding and firmly glued with specialized adhesive. Next is the propulsion system. He disassembles the old water jet pump assembly. The screws are rusted. Using a grinder with a wire brush to remove the buildup. Restoring a shiny metallic surface to the pump assembly. Placing the water intake assembly on the V-shaped bottom and marking it. And using a cutter to create a hydrodynamic intake compartment. The water-cooled two-stroke engine is lowered into the compartment. A green lacer ensures precise coaxial alignment. Drilling a hole in the stainless steel exhaust pipe, tapping threads, and installing a water valve. Water will spray in to cool the exhaust gas. Applying a dark gray primer coat, then covering the entire top half with a sky blue gel coat layer. The team flips the red boat hull upside down. Fiberglass and epoxy are added to the inner surface of the boat's bottom to reinforce the load-bearing capacity. The excess edge is trimmed sharply. The composite shell is now a solid unibody. Meanwhile, the top cover is taken out to the yard. An angle grinder is used to cut open the technical hatch. A sander smooths out the rough edges. A cut reveals the jet engine's air intake compartment. 2 core drill bits bore holes through the bulkhead. ADU0069E grinder widens the drilled holes to snugly fit an aluminum tube through, using a hammer to tap the aluminum tube through the boat's bulkhead. Using a heat gun to expand a PVC pipe section for the outer casing, beveling the tailwing sections to fit closely against the boat sides. Sanding and beveling the angles for a perfectly flush fit, rolling blue paint onto the vertical tail wings. The craftsman runs his hand to check the gap between the hull and wing. Applying masking tape. Applying specialized bonding adhesive along the gap, ensuring absolute water tightness. Using a high-speed sanding disc to smooth the newly applied adhesive layer. creating a seamless transition between the hull and wings. Applying stone powder filler and smoothing it along the edges. 2 large cylindrical tubes simulate the jet engines. Has been prepared. 6. Position the cylindrical tube in the tail compartment, drill holes, and securely fasten it with screws. The horizontal tail wing panel is chamfered. After centering, a cutter is used to create a cavity on the horizontal tail wing. Insert a steel rod to act as the core rotation axis. 2 aluminum tubes are positioned on the wing. Insert the vertical tail wing into the steel mount, and apply liquid glue for a rigid, secure hold. 4. Shape the profile using a utility knife. The frame of the boat's cockpit canopy is being molded from purple foam. Once the structure of the canopy is completed, it is wrapped with woven fiberglass mat and coated with a thick layer of epoxy resin. The resin spreads evenly, pressing tight against the curved walls. Chamfer the edges and use a sanding disc to smooth out all imperfections. Sand the canopy surface smooth and use a handsaw to cut small grooves to shape the edges. Tipex mold release wax is applied evenly. Cut a clear acrylic sheet. Use a gas blowtorch to heat and soften the acrylic sheet, and bend it tightly around the cockpit canopy mold. The high temperature makes the acrylic sheet flexible. He bends it to closely hug the curves of the cockpit canopy mold. Carefully apply masking tape as a guide, and use a file to trim off the excess acrylic sticking to the mold's edge. Insert a screwdriver into the gap, and pry firmly to separate the composite shell from the core. Use a hammer to smash the purple foam inside. The foam core is sacrificed to keep the canopy frame intact. Grind and trim the canopy details. Test fit the cockpit canopy onto the fighter jet body. It fits perfectly. Moving on to the landing gear assembly. The craftsman uses rubber wheels with pneumatic inner tubes for shock absorption. Assemble the front shock absorber using a wrench to tighten the axle bolts into the U-shaped bracket. Install the wheel into the shock absorber system. This landing gear helps the boat move flexibly on land. Checking the shock absorber spring. The threaded nut on top is tightened firmly. Press down on the shock shaft to test its elasticity. Attach an additional metal clamping mechanism. This is the steering transmission mechanism for the front wheel system. 1. Give the front steering axle a test spin. It operates smoothly. The wheel assembly is installed right under the bow compartment. 2. Restore the 2-stroke engine. Disassemble the rusty intake manifold and cylinder head for cleaning. Check the reed valve assembly. The reed pedals must be tight so the fuel-air mixture doesn't flow backward. 3. 4. Wash thoroughly with gasoline. The reed valve stopper is reinstalled. Apply gasket sealant to ensure the combustion chamber is airtight. 5. Connect the battery, pump the fuel, and test run the engine on land. The engine roars, ready to work. 6. The engine block is painted with heat-resistant silver, and the cylinder head is painted red. Mount the throttle control servo assembly onto the frame, and securely screw the servo in place. Connect the servo arm to the carburetor throttle using a small steel rod. This mechanism receives signals from the RC radio to open and close the throttle, adjusting speed remotely. Add a limit switch and chamfer the cut ends. It acts as a mechanically add emergency kill switch. 1. The completed engine block is carefully lowered and placed snugly into the engine compartment on the hull. 2. Apply black waterproofing paint to protect the compartment walls, where the water jet pump assembly is placed from water corrosion. Assemble the orange water jet stator. Tighten the bolts to secure the stainless steel exhaust nozzle that directs the flow. Moving to the nozzle control circuit. Dismantle the DC gear motor and use a hammer to remove the axle pin. A grinder trims away the excess corners of the board of the ESC electronic speed controller to make it fit. The gear motor and ESC are ready. Proceed to solder the power wires and connect the signal plugs. Test it via the radio controller. The motor rotates, responding extremely sensitively to every flick of the fight. Joystick. Mount the gear motor onto the steel bracket. This mechanical assembly is responsible for steering the water jet. To assemble the transmission rod connecting the jet nozzle of the pump assembly to the metal pull rod. Inject gray silicone sealant into the high-temperature gasket of the exhaust manifold. Use a drill to cut a hole in the plastic pipe. Attach a smaller pipe to create the exhaust system. Install a clear inline fuel filter into the middle of the bright red fuel line. Drill holes to attach the compartment hatch hinges. The builder mixes white and blue paint to create a sky blue color. The paint spray gun operates at full capacity. The camouflage pattern gradually appears on the aircraft shell. Install the weapon details on the tail wings. The cockpit is lined with luxurious red velvet carpet. A close-up of the completed engine compartment. The wires are still neatly bundled around the engine block. Turning on the radio remote control. The screen displays the signal synchronized with the boat. The jet nozzle steering system moves smoothly. The tail is fitted with red lights to simulate fire and smoke. The most important moment. Launching the fighter jet-shaped machine. The boat glides away from the dock. The jet propulsion system unleashes its power. The boat accelerates, tearing through the wind and running straight down the river. Performing artistic tight turns, the hull surfs the waves, showcasing excellent balance.